As with any other function, some rational functions can be graphed using transformations as long as the formula is in the right form and we know the graph of the basic function. So let's graph by transformation function f of x equal 2 over x plus 3 squared minus 1. The basic function here is the function 1 over x squared. This is the reciprocal of the square function and we know its graph. The second in the sequence of transformation, we are looking for the shift left or right, and therefore we are looking whether x is substituted with x plus something or x minus something. And here we have indeed, instead of x, we have x squared, we have x plus 3 squared, and that means that transformation that will take us from graph 1 to graph 2 is the shift left by 3. Then we are looking for horizontal stretches and compression and reflection, and therefore we are looking what is in front of the x in the formula. And there is just one. That means that there are no horizontal stretches or compression, or there is no reflection about the y-axis. So we are looking now for the vertical stretch and compression. We see that in our formula expression 1 over x plus 3 is multiplied by 2. So that means we have the vertical stretch by a factor of 2. And finally, we are subtracting negative 1 from the formula, and therefore this will result in the vertical shift down by 1. So the transformation we'll have to perform is shift down by 1. So let's start graphing. The first graph, the graph of the basic function, is already drawn on the left, and I will draw in the same coordinate system the graph of that function shifted by 3 units to the left. You have to remember, however, here that the rational functions have asymptotes. So the asymptotes will have to be moved as well. The function y equal 1 over x squared has two asymptotes. A vertical asymptote is x equals 0, this is y-axis, and there is a horizontal asymptote y equals 0. Now if I will be moving the graph to the left by 3, then the only asymptote that will move is the vertical asymptote. So I will start my graph with that new asymptote or new position to the asymptote. Asymptote is x equal negative 3 right now. And now every point on the graph of basic function is moved 3 units to the left. So the point negative 1, 1 will move to the point negative 4 and 1. Point negative 1 and 1 half and 4 is going to move to the point negative 3 halves and 4. Point 1 half and 4 is going to move to the negative 2 and a half, and 4. 1, 1 is going to move to the point negative 2, 1. And the point 2 and 1/4 is going to move to the point negative 1 and 1/4. So now we are ready to draw the graph. The shape is going to be the same as the graph of the basic function, only in a different place. So this is my graph number 2. Now this graph now has to be stretched 2 times. So on the right, in the right coordinate system, I will draw the graph number 3, and it's going to be in green. So now asymptote, if asymptote is stretched, then the asymptote stays the same because the y coordinate here is multiplied by 3, x coordinate doesn't change. So that line does not change. Asymptote remains at x equal negative 3. As I said, every y coordinate on the graph 2 will have to be multiplied by 2. So the point negative 4 and 1 will become negative 4 and 2. point -3/2 and 4 will become -3/2 and 8, way outside of my viewing area, and so point -2 and 1 becomes -2 and 2, and point -1, 1, 4 becomes -1 and 1/2. And we'll draw the graph that is a stretch of the graph number 2. This is the graph number 3. And finally, we'll have to move that graph down by 1. Remember that the graph also has horizontal asymptote, which is the x-axis. If I'm moving everything down, the x-axis or horizontal asymptote has to move as well. So this is now asymptote is y equal -1. The x-intercept, the x-vertical asymptote when moved down is going to remain in the same position. Now every point is moving down by 1, so we'll move every point that we used before by 1, and we'll draw the graph that is the shift of the graph by 1 unit down. And this is the graph 4. This is the graph of our function.